In this video, we will explore library of functions. Have you ever wondered why some graphs always look the same no matter the equation? Just like how we inherit features from our parents, these graphs belong to the same family. For example, all parabolas or absolute value share a similar shape like this. In this lesson, we will explore the library of functions, which consists of fundamental graphs known as basic or parent function. Knowing the function if even, add, or neither is useful in graphing it. Let us start with the basic function f of x equal to 3. This is a constant function and a linear. It means its graph is a line. Let us identify if this function is even, odd, or neither by evaluating f of negative x. As we know, in this given, for every real number x in the domain, there's always one output y, which is 3. So if we will evaluate f of negative x, we will replace negative x for every x in the function, and the answer is always 3. And this f of negative x is simply equal to f of x. So that is why this function is even. And to graph a line, we need at least 2 points. So if we will start substituting for x equal to 0 and for x equal to 1, so we have these 2 points. And then connecting these points using a straight line on the right, so we have this line. And since it is even, and we know if it's an even function, then it is symmetric. The graph is symmetric with respect to y-axis. So we can extend this line and reflecting on the y-axis. So that completes the graph of the line. Let us consider another function, which is f of x equal to x. This is called an identity function and also a linear. For every x, there's always the same value of y. So let us identify whether this function is even, odd, or neither. So since f of negative x is equal to a negative x, and this is equal to negative of f, then we can say that this function is an odd. And to graph a line, we need at least 2 points. So let us start substituting x as 0 and 1. And connecting these 2 points using a straight line. So the graph will be like that. And since the function is an odd, we can extend and graph with symmetry at the origin. So that's a graph of f of x equal to x, which is an identity function. In these two linear functions whose graph is a line, the first one, its slope is 0, while the other, its slope is 1. Another linear function that we will consider is when the slope is not 0 and not 1. This given linear function is neither even nor odd. Though we can put any x values, let us place x equal to 0 and 1 and plot the 2 points. Then connecting these 2 points using a straight line, so this is the graph of f of x equal to 2x minus 1. And the next is the absolute value function. Its basic function is f of x equal to absolute value of x. It is an even function, and let us assume two x values again, like x equal to 0 and x equal to 1. Then connecting these 2 points by a straight line. Then since it is an even function, we will complete its graph by reflecting it in the y-axis. The next function is a square function, given its parent function or basic function as f of x equal to x squared. And we know that this is an even function. Substituting x values again with x equal to 0 and x equal to 1, and connecting these 2 points using a curve because x squared is not a line or is not linear. And then since we know that this function is even, we can complete its graph by reflecting about the y-axis. So that's the graph of the square function. The next one is the square root function, which is f of x equal to square root of x. And this is neither even nor odd. So if we will substitute values, we can assume only non-negative values, like x equal to 0, x equal to 1, and we can add another point or x value, which is x equal to 4. And then connecting these 3 points with a curve, not a line because it's not linear, then we can have this graph. Take note, we cannot put any negative values, so that's why there's no graph on this part. Now for the cube function with basic f of x equal to x cubed, and we know that evaluating f of negative x, it will give us negative of f, so it is an odd function. And since x cubed is not a linear function, we're expecting that the graph is not a line, so it's a curve. So we can assume some points like x equal to 0 and x equal to 1. So we can have 0, 0, and then 1, 1. If you will continue with x equal to 2, so the y value will be around 8. So here, so it's 2, 8. And then we can connect these 2 points using a curve, not a line. So we can have this graph. And then this function is an odd function, then we can complete its graph by reflecting it with respect to the origin. So that completes the graph of the cube function. For the cube root function, which is f of x equal to cube root of x, so we can substitute any real number here because it's an odd root. And as we know, this f of negative x is equal to negative f, so it means it is an odd function again. And then let us start substituting real number here, like 0 and 1. So we have 0, 0, and then 1, 1. And if we will continue, I will choose substituting 8 to have an exact output. So we have cube root of 8 is 2. So we have 8, 2. So the point is around here. So connecting the graph with a smooth curve and reflecting this with respect to the origin because it is an odd function, then that completes the graph of the cube root function. Now the last but not the least is the reciprocal function with two different given. The first one is 1 over x and the second one is 1 over x squared. So in both of this, xy cannot be 0 because division by 0 is not allowed, and y cannot assume the value of 0. In this exclusion in the domain, it can reflect the graph as an asymptote. So when x is not equal to 0, that is a vertical asymptote in the graph, and when y is not equal to 0, then that is horizontal asymptote. Now, evaluating the first function as f of negative x, so we know that this is equal to negative of f, then this is an odd function. So we can now substitute some values in x like x equal to 1, x equal to 2, and x equal to 1/2 to have an exact output. And then, since we know that this is not a linear, so the graph is not a line, so we have to connect this using a smooth curve asymptotic to this two asymptotes, like this. And then to complete its graph, we can reflect this about the origin since it is an odd function. So that's the graph of 1 over x. Now let us complete the graph of the second reciprocal function. So by evaluating f of negative x, so we can see that this is equal to f of x because the power of x here in the denominator is even. So we know that this is an even function. So we can now substitute some values of x similar to the first one. So we can have these 3 points and connecting this using a curve. And then now, instead of reflecting about the origin, like on the first one, since this function is an even function, we will reflect this curve about the y-axis. So that completes the graph of reciprocal function. So these are the basic function. Actually, there's more, but we can discuss that in the next sections. Thank you. So that is the end of this video. If you find this video useful, please like and subscribe and turn on the notification bell so you can never miss out any future content. Thank you.